Hi everybody. We're going to talk about the binomial and using tables. So we have two tables. Table 1, and that has the case when x is equal to something. Okay, just equal as it stands. Table 2 is the at most or less than or equal to. Okay? And remember, these are context driven. So you're going to be given n. Come on, pen. You're going to be given n. Pen is being hostile. Why? You're going to be given n. Because I'm leaning on. Okay, n is given. P is given. That's your probability of success. And your x is going to be given. Remember, all these are in some kind of a story. All right? So let's take a look at the tables and see what we can come up with. Okay. So look at our table 1, and this is the just plain equal to. So you've got n on the extreme left, you've got x one column in, and the various values of p going across the top. So let's just say for argument, I want to look up n equal to 6, and p is equal to 0.7, and x is equal to 4, just for fun. So here's 6 and 4, and 0.7 is way over here. So that's just going to be 0.324. And that's all you have to do. It's like playing Battleship. You line up the rows and the columns, if you ever played Battleship. Okay? So they're pretty straightforward. Alright, and that's for just plain equal to. So what about the at most? Alright, let's take a look at that table. That's table 2. And hang on. Okay. So here's our table 2. You still have the basic framework is the same. So you've got n and x and the p going across the top. Now this one is cumulative. So it's adding up the values from the previous table. So if we look at 6 and 4 and 0.7, you're going to see a different value here. You're going to see 0.580. Why is that different? Let me show you. If I go back here, if you look at the previous pages and you add them up, you will see that you get the 580. It won't let me flip back and forth. It will override the recording, but essentially that's what's going on. Okay? But yeah, if you just add them up, you will see that it adds up to the 580. So it's cumulative. All right? So you're thinking, yeah, right, whatever. This sounds pretty lame. So let's try some problems, and I put together a little problem for us to work on. So let's load that up. Okay. You can see, oh, you want to see all my pictures from my vacation in last spring break? can show you that. And my dog who went to heaven last spring, before I got the one who's here snoring on my lap. Okay, where is it? Here it is. All right. Okay, let's take a look at our problem. So we're going to talk about schnauzers. And we have miniature schnauzers, and we have 10 of them. And the probability that if you pick a schnauzer at random, that he or she will be white, that's about 0.2. Okay? Most of them are that nice salt and pepper, that gray that you always see. But there are a few white ones. Yes, I've had one. All the rest of them have been salt and peppers. The one I have, or actually the dog I have right now is a mutt, and she is snoring right here next to me. And if I take a random sample of 10 miniature schnauzers, what is the probability that exactly 2 of them are white? So I have n of 10. That's my number of trials. Okay? How do I know this is a binomial? Because my options are 2. Okay? Either they're white or they're not. So that clues me in. Then exactly 2 that says, okay, it's going to be the probability that x is equal to 2. That tells me to go to table 1. And finally, I have probability of 0.2 that goes from the 20%. Okay, so as I mentioned, everything is context driven, and we can find it from there. All right, so let's take a look. Let's go to, that's right, it won't let me go back into table 1, so I'm going to have to reload it. So just be patient for a minute. So I'll go to the next, go back here and reload table 1. Sorry about that. I thought it would let me go back and forth, but it won't. I learned that. Okay, let's take a look at this. So we have n of 10, x of 2, and if we scoot over to p of 0.2, we're going to have 0.302. So you always have where rows and columns meet, that gives you your probability. Okay, and that's all there is to it. When you have the x equal to, that's one shot thing. All right? So the probability that x is equal to 2, that is the probability of exactly 2 white schnauzers, is 0.302. Okay? Then for the second part, I have to reload the file, so just give me a second. All right, for the second question, this time we're taking a sample of 20, and we have that magic phrase at most. So that means x is less than or equal to 3. Aha, that tells me right to go to table 2. Okay, and we still have the same p of 0.2. So we're going to have to reload table 2. So hang on a second. All right, so now we have, since we have 20 schnauzers, here's our 20. It's at most, so it's cumulative. So we have 20, 20 and 3, and scoot into 0.2. So we have 0.411. So that means that our answer is 0.411. That is the probability of at most 3 schnauzers, 3 white schnauzers is 0.411. Okay, hope this helps.